Okay, so we have come to stationary points, and I have actually 3 graphs over here. Okay, basically for stationary points, you must always remember dy dx equals to 0. And my dy dx stands for gradient. Okay, we have covered a few types of stationary points. Okay, one is called maximum point. And just now as we mentioned, maximum points are A and C. Okay, whereas for minimum points, okay, it's B and D. But all these 4 points have something in common, which is that dy dx equals to 0. And another type of stationary points that we are going to learn are called points of inflection. Okay, points of inflection are something that is different from maximum and minimum. Okay, because unlike your maximum point, which changes from positive gradient to negative gradient, or minimum point changes from negative gradient to positive gradient, okay, your point of inflection doesn't change the nature of the gradient. Okay, what I mean by that? Okay, before this point, dy dx is negative. After the point, dy dx still remains negative. Okay, that is a point of inflection. Okay, whereas for the other example, it's a point of inflection because dy dx is positive before the point. After the point, is still positive. But I say it again, okay, your dy dx is always 0 at all stationary points. Okay, now we'll try some examples in the textbook. Let's come to this question, okay, and I see the word stationary point. Okay, what does it mean? So when I see this word, what it means is that I must find dy dx and later equate it to 0. Okay, after I find dy dx, remember I will equate it to 0 because that is a stationary point. And look at how I simplify it so that it's easier for me to F it. F it meaning factorize. After we factorize, we will just find the coordinates. Okay, my 2 stationary points. Okay, so my 2 coordinates will be 3, negative 22, and negative 1, 10. Okay, so I've already found part A answer. We come to part B. I want to find nature of points. Okay, it's just determining whether is it minimum, maximum, or point of inflection. Now I'll show you what is first derivative test. Okay, basically we will start with on the first column x, dy, dx, and curve. Okay, and I will have to put 3 points for x. Okay, when x is 3, what is dy, dx? Okay, basically just to explain, I will sub in the value just right before 3. Okay, 2.9. This 2.9 sub into dy, dx. Tell me what is the nature of the gradient. So we calculated dy dx before the point would be negative, okay, less than 0. How about after? Let's sub in a value that is just right after 3. What's the number that is right after 3? 3.1, thank you very much. Sub in 3.1 into dy dx, what do you get? Answer 1.23, which is positive. Now, okay, I will draw the curve. Okay, we will conclude the shape of the curve. The first point is a minimum point. Okay, now I'm finding the nature of the other stationary point, negative 1, 10. I start with negative 1. At x equals negative 1, what's the gradient? 0. Yes. What is a point that is slightly before negative 1? Okay, then afterwards I will sub negative 1.1 into dy dx. Basically 1.23, which is positive. Okay, now on to a point that is right after negative 1.1. What's the number right after negative 1.1? Cannot be 0. Okay, slightly a bit more. Negative 0.9. Okay, sub it in. Your dy dx should be negative 1.17, which is negative. Because after your dy dx, okay, please draw the curve. How does it look like? Okay, and it is a maximum point. Okay, so I found my 2 stationary points indicated the nature of each of the stationary points. Now for the last part, okay, we sketch the graph, okay, and first of all, please find the critical values, meaning what are my roots of the equation. Okay, I can get these values from calculator, okay, by solving the cubic equation. After we find critical values, write it on the graph. Okay, these are the points that it cuts x-axis. Okay, what it means is that the curve will definitely cut at these 3 points. Next is to do my maximum minimum point. Okay, so I've already indicated my x-intercepts, okay, in green. Okay, my stationary points, minimum, maximum. Okay, and there's a last one, which is the y-intercept. So for y-intercept, just make x equals to 0. Okay, once you do that, you realize that it cuts at 5. So the last step is to combine, join all these points in one smooth curve. Remember, this is a sketch, so it doesn't have to be very exact, but it needs to have all these critical points, 1, 2, and 3. Okay, so this is the final sketch of the curve. Make sure to extend the curve after you are done, okay, because it's a cubic curve.